Tutor, where school is made simple. Let's go.
One of the most difficult concepts and topics for students in pre-calculus or calculus is the limit definition of a derivative. How do we come to this seemingly magical formula that gives us all this information? Well, first we start by looking at the definition of tangent and secant. If we go back to geometry, we remember that a tangent line will touch a graph once, whereas a secant will touch a graph twice. Now, let's start by identifying a point A. And we're going to create a tangent line through point A and tangent to our function f of x equals x cubed plus 3x squared minus 8x plus 6. Now, to look at a secant line, we would have to find a second point B and then plot a line between these 2 points that would pass through multiple times, making it a secant line. Now let's look at these 2 lines and how they compare one another, the secant line to the tangent line. And one of the things I'm going to look at principally are their slopes. What are the slopes of my tangent and secant line, and how do they compare numerically? If I move B around, I see that my slope changes. As I move it further along the x-axis, I see that the slope does increase, but it's not getting anywhere close to the 16 of the tangent line. And if I move it back, well, it's changing drastically. It becomes negative, and then over here, it's now going to move towards a positive value again before we pass over this last vertex. And now, as we move closer to A, as B moves closer to A, we see that the slope of our secant line is starting to approximate the slope of the tangent line, which means if we look at our 2 graphs, we see the secant line is close to overlapping the tangent line. So that as the distance between A and B decreases, our secant line begins to approximate the tangent line until B becomes A and our slopes become equal. So now let's look at what this means algebraically. Let's go back to pre-algebra and algebra, and let's start by identifying these 2 points. Well, look at where they are on the x-axis. I define point A as having an x, and then point B is some distance h away from x, therefore x plus h. Correspondingly, where they cross the function, my axes, my coordinates will be x comma f of x and x plus h comma f of x plus h. Then what I was looking at before is when we move B closer to A, I decrease the distance. Now, what is the distance between these 2 points? If I look down here, the distance between x plus h and x would be x plus h minus x. Drop the parentheses, I get x plus h minus x. X minus x is going to give me 0, plus h would give me h. So h represents the distance between these 2 points. Now I'm going to use that to look at the slope of my secant line. The slope of my secant line is change in y over change in x, or y2 minus y1 over x2 minus x1. If I simplify this a little bit and plug in x comma f of x and x plus h comma f of x plus h, then I see that my slope is going to be f of x plus h minus f of x over x plus h minus x, which is h. Now, I say that when my distance goes to 0, when my distance becomes very small between A and B, that my secant line will become my tangent line. And this is what the definition using the limit says. It says the limit as the distance between the 2 points goes to 0, of f of x plus h minus f of x over h will give me the slope of my tangent line. And that is where the limit definition of the derivative comes from.